Hello, hello, it's Miss Lawson here. For today's demonstration / hands-on lab, you will need an empty water bottle, a marker, a straw, a ruler, a small amount of modeling clay or poster putty, some isopropyl alcohol. If you've never heard of that before, it's the same thing as rubbing alcohol. For today's purposes, I found one that doesn't have a green tint to it. If you have rubbing alcohol at home, but it's not clear like mine, it's all right. But if your rubbing alcohol is green, let's use green food coloring instead of red. Mine doesn't have any color, so I'm going to use red. We'll also need some water, some warm water, and some cold water. Here's how we're going to get started. First, we're going to put a scale on our straw. Now, what does that mean? A scale. We're going to put a scale on our straw. That means that we're going to be putting marks on our straw so that we can more easily see the changes that occur in our thermometer. For me today, I think I'm going to put marks about every quarter inch. So I have one here and here and here. If you're not sure what a quarter inch is, it is just 1/4 of an inch. I'm making marks at 1/4 of an inch increments. I'm going to do that all the way up my straw. It's not super precise, but that's okay. We're not making super precise weather instruments. It doesn't have to be super precise for us. It just needs to show what we prefer to show. All right. I put a scale on my straw. In other words, I put marks in equal increments all the way down the length of my straw. That's my first step. Here's my next step. I'm going to open up my empty water bottle. I'm going to add a 1/4 cup of water, which I already have measured out. And then I'm going to measure out a 1/4 cup of isopropyl alcohol, rubbing alcohol. Here's my 1/4 cup of water. I'm going to need a 1/4 cup of rubbing alcohol. I think it might be better to put it in this. This has a nice pouring spout. This does not. Thank goodness that I don't use this for food. One word of caution for you guys. If you're using nice measuring cups of your parents and you're putting chemicals in, like isopropyl alcohol, make very, very certain that it gets completely washed and cleaned afterwards so that you don't accidentally get your folks sick. All right, I have my 1/4 cup of water. I have a 1/4 cup of rubbing alcohol. That's going to go in my empty bottle. All right. I'm going to add about 3 or 4 drops of food coloring to my bottle. 1, 2, 3, 4. Yeah, perfect. For now, I still have my cap. I'm going to cap up my bottle and shake it just a little bit to get all that color nice and incorporated or mixed in. Take the cap back off. Here's the next part. This part can be a little bit tricky. Let me explain to you what I mean. We're going to be putting this straw into our bottle, but it needs to be in the liquid and not touching the bottom. Let's see if I can show you that. All right, so my straw is going to be in this liquid, but not so far down that it's touching the inside of the bottom of my bottle. Now, the way that I'm going to do this is I'm going to take my straw with its nice little scale going on. I'm going to take some of this nice modeling clay. I'm going to roll me out a chunky snake or a weird hot dog shape. I'm going to wrap this. Actually, first I'm going to see how low it needs to be. Yes, about there. I'm going to wrap this guy around the end of my straw. This clay will work like a stopper. Keep my straw from falling all the way down and touching the bottom of the inside of my bottle. It'll also be good to keep extra air out of the inside of my bottle because If there's too much air going on, you're not going to be able to get a very accurate temperature reading. I'm going to fix everything up here in the top. All right, my straw is in the water, but it's not touching the bottom of the bottle. My marks, my scale, that's on my straw. Next, what we have to do is test this out. This is our thermometer. Remember how particles react to heat and cold. Whenever particles are heated up, they move around a lot more and they get farther apart from each other. This makes the liquid expand or take up more space. And as it expands and takes up more space, it's going to be traveling up our straw. I have some cold water. We all know what happens to particles when they get cold. They start to slow down and they move closer together to try to stay warm. They probably aren't trying to stay warm, but they do move closer together. Particles become more dense whenever they are cold. That should cause our fluid level to drop. Let's check it out. All right, second grade friends, beautiful, wonderful, shining faces. We are going to be testing out our thermometer. As you can see, I have 2 containers of water. One is quite warm, so warm in fact that it is creating water in gaseous form. Do you guys see the steam coming off of this? That's a gas. And I also have water that has a couple of chunks of ice in it, just so that it's nice and frigid. I'm going to grab my thermometer, and hopefully you guys will be able to see that as the water expands, it's going to begin to travel up. If I keep holding this here, I'm pretty sure this water in the straw would go all the way up. Oh, it did. It went up to the top. It's dripping down the sides. Oh my, what a world, what a world. But if I put it into this nice cold water, oh wow, see how rapidly the water level goes down? My thermometer! Whew, she works. She's not very sturdy. She doesn't like to stand up on her own, but she works. My levels have gone back down. I'm going to put it back in the hot water and see if I can get my level to rise again. As those particles start to be heated up, they start moving around more. As they move around more, they take up more space. They expand. This is what's causing our water level inside of our straw to rise. About right in here. Oh, it's getting some higher. It's getting some higher. And if I put it back in the ice water, kerdunk. See how the level is going down, down, down. Slowly yet surely going down. This is how thermometers